Right. Welcome again to our third lesson on functions. Today we're going to be looking at finding the range of a function when the domain is restricted. Now, if you look at this function here, the function is f of x equals to 3x minus 2. Now, the domain here is not just all values of x. The domain here is restricted for between 1 to 4, 1 included and 4 included. So for this function, we're not going to use x being 5 or 6 or 7 or 8, anything more than 4. At the same time, we cannot use anything less than 1. So something like 0, -1, -2 behind this cannot be used because the domain is being restricted. So what we're doing today is to find out what the range is going to be, what the output is going to be, what values y would be when x are just within these boundaries. So that's what we're doing. Now, so the first example is going to be about linear function. Now, linear functions are normally in the form of y equals to mx plus c. Now, if you plot this one, you will always end up with a straight line, whereby m is the gradient, for example, 3 is the gradient of that line, and whereby the c is the y-intercept, where the line crosses the y-axis. So if you look at the equation y equals 3x minus 2, and I've plotted it here, if you look at it carefully, you can see that the line crosses the y-axis at -2, and you can see that the gradient is basically a +1, which is basically 3 here. So that's the line. Now, remember that to plot the function, the line, you will always need to know your x values. Here we are starting at 1 and ending at 4. Now, when x is 1, let's see what y is going to be. Okay, so when x is 1, so you put 1 inside there. Let's see what the output is going to be. Now remember, we always times where x is, that's x there, you put your input there, which is 1 there. So anywhere where x is, you just put 1 for that. Plus 2 over there, but it's not actually plus, actually minus. So that's going to be -2. Okay, like that. So now we have 3 times by 1, which is 3 take away 2, is going to be 1. Now, so I want you to notice that when x is 1, y is 1. And that's what it's showing us here. So when x is 1, and x 1 being the smallest one, we are finding the corresponding range or y value or output of 1 over there. Okay, so that's the minimum. Now, let's look at the maximum value where x is 4. Let's see what we end up with y. So when x is 4, what is y going to be? Or what is the output going to be? Okay, again, we set it up. We say that f of 4 equals to 3 times by 4, take away 2. So 3 times 4 is 12, take away 2 is going to be 10. So when x is 4, y is 10. Or when the input is 4, the output is 10. So let's go to the graph. So you can see that when x is 4 here, y is all the way at 10. Now, you can see now that we have two boundaries of y. We have 1 at the minimum, and we have 10 at the maximum. So that's going to be the range now. Okay. So we now say that the y values, which is our range, f of x, lies between 10 and 1. Okay. So when the domain is between 1 and 4, then the range is between 1 and 10. 1 and 10 included, because the 4 up here was included, because it says x is less than or equal to 4, and here it says x is bigger than or equal to 1. So 1 and 4 included, therefore the 1 here and the 10 there are also included. So when it comes to straight line, very easy. All you need to do, sub in the lowest value and sub in the maximum value. They will give you the corresponding maximum values of the y, which is basically the range. So at the bottom here, it says the range of f of x is such that f of x is less than or equal to 10, and f of x is bigger than or equal to 1. Okay. Now, what I want you to do now, I would like you to pause this video. And for question 2, I would like you to find the range of each function. Remember, all these ones are linear functions. So all you need to do is just to sub in the minimum value of the of x and then the maximum value of x to find the corresponding values of the range. So pause the video and have a look. Okay, well done. So I hope you've had a go at that. So what I'm going to do now, I'm going to try question F for you. Let's just go through question F. It looks a bit different and see whether there's a difference. Now, before we start, I'm going to remind you that this one is basically a linear function whereby x over 4 is the same as 1 over 4 x. It's the same thing. And when x is not squared, then it's not quadratic function. It's not quadratic curve we're going to end up with here. It's just basically linear. And I can add 0 here, so then you have the concept of y equals to mx plus c, where c is the y-intercept and m is the gradient. The gradients are quarter here. So this line is going to be passing through the origin, and the gradient is going to be positive, which is going to be 1 over 4. What I want to do now, I want to find the highest value of y you can end up with and the lowest value of y you can end up with here. So all we need to do, as I said earlier, you just sub in those values. So let's sub them in. Okay. So f of x, we got f of x equals to x divided by 4. Our highest value there is basically 8. So we say f of 8 is going to be equals to 8 over 4, which is going to be 2. So the first value you're having there is a 2. Now the other one is f of negative 4 on the lower side. Negative 4. So that's going to be negative 4 divided by 2, which is going to be negative 2. So our range f of x is going to be between 2 on the higher side and negative 2 on the lower side. Now notice that f of x is bigger than negative 2. We're not going to add that line at the bottom because it's not part of it. And how do I know that? Because this one here doesn't have the line at the bottom. So actually this negative 4 is not included, it's just a boundary. So this also just a boundary, so it's not part of the answer. However, because 8 is included, the 2 here is also going to be included. Okay, so we're done for that. So I'm just going to show you the answers, so then you can pause the video and just mark your work quickly. There you go. So you just want to mark your work quickly. As I said earlier, the linear functions are very easy. Just sub in those two values and then you get the maximum and the minimum. Okay, we're going to now proceed to the next one. I would like you to pause the video and then try question 3. But before you try that, I'm going to just pinpoint something. Now, when you have quadratic functions like x squared there, then I want you to think about it this way. I would like you to think about it, that the minimum value of the domain, say for example the 2, does not necessarily give you the minimum value of y or f of x. And the maximum does not necessarily give you that. So I'm going to show you why. Pretend you have quadratic function. Pretend you have quadratic function like that. And you have that line there. This is y equals f of x. Now y equals x squared, sorry. Now let's pretend that this point here is negative 3 and this point here is going to be 3. Now if I square these 3 here, I'm going to end up with 9 at the top there. So 3 squared, because that's what the function says, if you square 3, you're going to end up with 9. So let's say that that was my domain. The domain was less than or equal to 3. What I'm ending up with, that the f of x, yeah, the value of the range is basically going to be 9. Now what about on this lower side? If I'm squaring negative 3, I'm going to end up with the same thing. So if x, if x is bigger than or equal to negative 3, what I'm ending up with here is that f of x is again being equals to 9. You see that? So think about it. So I could add my equality sign here, put it there as -3. The value of x being between -3 and 3 basically. All right. So if I'm using these boundaries, you can see that this -3 is not giving the minimum value, and this 3 is actually giving the maximum value. So therefore, there's something special you need to understand when it comes to quadratic functions. Now, with the quadratic function, for example, y equals x squared, can you notice that the minimum value of f of x of y here is 0? I get it. So I'm going to now say, based on this function, if my function was f of x equals to x squared, for example, and the domain is from -3 to 3, then I can see that my range, f of x, the maximum of my range is 9, yeah, so less than or equal to 9. And I can see that the minimum now is going to be what? Equals to or bigger than 0. So when it comes to quadratic functions, I would say it would be a good idea for you to sketch the graph so then you can visualize it. Sketch the graph and visualize it. The maximum and the minimum values of the x does also necessarily give you the maximum and the minimum for the range. So it's always a good idea just to sketch them. So I'm going to ask you to try question A and then try question B, C, and D, please. So pause the video and try those, please. Okay. Right, so hope you've had a go at question 3. What I'm going to do, I'm just going to pick quick questions. I'm going to pick question C, and then I'm going to pick maybe question D. So let's try question C. And with C, I want to do it by sketching it first. So my function here says f of x is equals to x squared minus 1. Now, if you've done transformations, I want you to think about this x squared being my main function. And what's basically happening is that I'm taking away -1 from it. So if I just ignore that and just look at my f of x being x squared take away 1, then I can see that what is basically happened is that the next part is that I'm taking away 1 from this f of x. Because if you take f of x to be x squared, then x squared minus 1 is the same as f of x minus 1. So all I can do first is to sketch this graph first and then just translate it down by a factor of 1. Think about f of x. When you're adding or taking away a constant, what happens to the curve of the graph is that it's always translated by a units up or by a units down. So in our case here, the graph is going to be translated down by a unit of 1. Okay. So with that, I'm going now to sketch my graph. I'm going to sketch my first graph. How the first graph is going to look like. So I'm just going to draw it here. And then I'm going to do that. If I extend the back, I'm going to have something like that. So x squared. So when you do x squared also do something like that. Coming up like that. That's x squared. That's the first one. This is just basically y equals x squared if you want. But then after that, we need to take it by up to level 1 down. So that means that basically to level 1 down, this basically means -1. So this 0 here, this level here, I'm going to take it down to that point. Okay. So if I draw a new one, we're going to have something like this. Okay. If I extend that part, we're going to end up with something that looks like that. Okay. So this point here is going to be now -1. Do you see? So this graph straight away, I can see that f of x, the lowest possible f of x is going to be on -1 at the bottom there. Now what I want to do is now to find the highest. I want to find the highest level that this can go. Okay, now to do that, I'm now going to use this and I'm going to use that. So now let's use 3 first. So I'm going to say that let x be 3 on that. Now when x is 3, the y is going to be 3 squared minus 1. Okay, so it's going to be 3 squared minus 1. If I write that separately. So when x is 3, then y is going to be 3 squared minus 1, substituting as normal. So we got 9 take away 1, which is basically 8. So when x is 3, the y is going to be on level 8. That one there. Now let's see this one here. Let's see what about on the negative 2? Does it give us something lower? Okay, let's find out. So if that is that's 3 there, then let's pretend negative 2 is somewhere here. Now if you do negative 2 squared, so negative 2 squared is 4. 4 minus 1 is going to be 3. So when you have negative 2 there, then this is going to be actually stopping somewhere here, where 3. So let's pretend 3 is somewhere here. Okay. So this end will just basically stop somewhere there. So negative 2 doesn't give me the minimum value for the curve. Negative 2 is giving me a 3, which is much more bigger than negative 1. So what is the minimum value? Negative 1. And what's the maximum value? It's going to be 8. So my answer is going to be f of x lies between 8 and negative 1, like that. Okay, so that's all for that. Now I would like you to have a go at the rest as well. For example, the 2x squared. Plot the graph first and see which value or which value of x is going to give you the minimum, and then compare with the answer I'm going to show you in a minute. Question 3 particularly looks like A-level work. So when you go to year 12 of next year, you're going to do a little bit more of these ones. Okay. So I'm just going to show you the answers quickly so that you can mark your work. Brilliant. There you are. So mark your answers from question 3A all the way to D. Okay, hope you've just marked your work. So thank you very much for today, and that's the end of today's session.